Time to review types of reactions, so you'll do really well on this worksheet, but even more importantly than that, so that we will tell by your test that you understand this section we've been studying on types of reactions. So a few terms here for you to consider, and see if we can make this small enough so you can read the entire term while I'm still writing here. There we go. So we've been writing a lot of chemical reactions, like, well, for example, one of my favorites, this reaction you did in lab several times, burned hydrogen by combining it with oxygen in the air, lighting a match to it, makes a boop sound, and you just went, and dropped the test tube and it shattered all over the place. Yeah, well, so remember, when you look at that you remember these substances or species that we start with are called the reactants, and these substances or species that we make, the things we produce, are called the products. So don't forget that. And also, then the next thing that's on this review sheet study guide is the different types of reactions that we have looked at. We've looked at single replacement, or often called single displacement reactions, and they take the form of some element by itself combining with an ionic compound that's usually in solution. And if this A happens to be a metal, it'll replace the cation, and it will lose electrons to the cation, and the cation will become a pure element. And oops, let me get that right. Yeah, the cation will be a pure element, and A will be combined with X because A has lost electrons. Now, there are a lot of cases where of course, if A is a nonmetal, A would probably gain electrons from X and step in here and replace X, and X would become the element that's out by itself. So that's one type of reaction we've spent some time looking at. The second type of reaction is double displacement or double replacement reaction, and it usually takes the form of two ionic compounds that are, one of them at least, in solution. So when you dissolve the other, they both end up being in solution. And the cations simply trade places. Now we'll look at some of the reasons for this in a future chapter when we study solubility rules and try to get an understanding of why these reactions occur and when they occur. So that's another type of reaction we've looked at. So the product here, A would no longer be combined with X, A would be combined with Y, and B would form. So double displacement reactions, two ionic compounds trade cations to form new compounds. Now, synthesis reactions, when two or more substances combine to form a compound. And the thing that a lot of you noticed on the worksheet was we took carbon dioxide and water, and a lot of you remembered from biology class that those made oxygen and glucose. And you called that process photosynthesis. Decomposition reactions. Yeah, I know, you wanted me to do that, didn't you? To balance those. Decomposition reactions, we have a single, notice that's really important there, that if you have a single compound by itself, maybe something like copper carbonate, you put that in the test tube in lab and you heated it, a single reactant. If you only have one reactant, it has to be decomposition. And so that would decompose into copper oxide and carbon dioxide. And so this gas put out a burning splint when you tested that in lab. Combustion reactions. In combustion reactions, oxygen combines with a substance and you get energy released in the form of light and heat, and you usually think of that as fire, and it's burning. And so you take a piece of calcium. We probably watched a video of this. We didn't do it in class because it's a little bit on the violent side. Take calcium, combine it with oxygen and heat it, and it makes a huge fire, and it makes calcium oxide. Hydrocarbon combustion is a little more specific. Now, by the way, this could also, we couldn't count you wrong for calling that synthesis, could we? Well, I don't think I could. But it is a combustion reaction as well. Hydrocarbon combustion is pretty specific. You have some kind of compound that contains carbon and hydrogen. Maybe the methane gas like we burn in our Bunsen burners in the classroom to produce CO2 and water. Well, it doesn't matter what the hydrocarbon is that's right here. If you burn it in the presence of oxygen and it's a hydrocarbon, that hydrocarbon is going to always produce CO2 and water. Hydrocarbon combustion. Now that could be, true for alcohol or gasoline or whatever the compound is that you're burning. Now, as we're working with these reactions, we've spent a lot of time balancing the chemical reaction. And so as we come to this next term, number 9, I want to talk about that a little and just remind you that if you see something like H2O plus O2 making H2O, we balanced these reactions. Well, first of all, we wrote every formula correct. We know that this is water, so we wrote that. If we change it, if we put a 2 here to try to balance the equation, it's not water anymore. That's hydrogen peroxide. Oh, wouldn't want to taste that. Well, I've tasted it. Have you? You don't want to try it. Okay. So we balance this by saying, well, to get... Oh, one other thing. Yeah, why did we write O2 and H2? Because we have 7, count them, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. 7. We have 7 elements that in nature always occur in this diatomic form. So make sure when you're writing those in formulas, when you're writing them in chemical equations, you have to write the formula as diatomic. So that's why we wrote O2 with that diatomic feature. But because we have an O2 there, we don't have enough oxygens here. And we can't just destroy oxygens in chemical reactions. Has to be accounted for somewhere, so we use coefficients to balance these. So we balance that oxygen by putting a 2 there, and that goes through the entire formula to give us 4 hydrogens and 2 oxygens. But if we have 4 hydrogens, we're going to have to put a 2 here to give us 2 times 2 and give us 4 hydrogens on each side of the equation, and 2 oxygens on each side of the equation. So, as a result, what we can tell when we look at this equation is that if we have 2 moles of hydrogen and we combine that with 1 mole of oxygen, we will produce 2 moles of water. That's where that's going to be important, and we'll use that a lot in the next unit that we look at. So that's what we call by balancing chemical reactions. Balancing chemical reactions is when we represent the chemical reaction that shows how reactants form products, and we conserve the total number of each kind of atom. Total number, 4 hydrogens, 4 hydrogens. 1, 2 oxygens, and because of this 2, 1, 2 oxygens. That's balancing the chemical reaction.